this episode, we're going to take a calm, beginner-friendly walk through an AI system lifecycle so you have a clear picture of what actually happens from the first idea to the system running in the real world. A lot of confusion in AI security comes from treating AI like a magic box that appears fully formed, when in reality it is built and operated through a series of decisions that leave fingerprints everywhere. Those decisions involve people, data, software, and business goals, and every step creates different risks and different chances to prevent problems early. If you can describe the life cycle in plain language, you can also understand where security, governance, and compliance fit without feeling like you need to be an engineer. This life cycle view will also help you make sense of exam questions, because many of them assume you recognize where in the life cycle a decision should happen. The goal is that by the end, you can explain the life cycle as a simple story with clear stages and clear reasons each stage matters. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. An AI system lifecycle starts long before anyone trains a model, because the first step is always purpose and problem framing. Someone in the organization has an idea, like using AI to summarize customer messages, detect fraud, recommend products, or help employees find information faster. This moment seems harmless, but it is where the system's scope is set, and scope controls everything that follows. If the purpose is unclear, teams may collect unnecessary data, measure the wrong outcomes, or deploy the system into situations it was never designed for. Security concerns also begin here because the purpose determines what kinds of harm are possible, such as privacy violations, unfair decisions, or incorrect outputs that cause financial loss. A beginner can think of it like planning a road trip. If you do not know the destination, you cannot choose a safe route, you cannot estimate fuel, and you cannot know what supplies you need. In AI, purpose is the destination, and it shapes every decision about data, controls, and accountability. Once the purpose is framed, the next stage is defining requirements and success criteria in a way people can actually test. Requirements include business needs, like speed, accuracy, and cost, but also include security and compliance needs, like protecting sensitive data and limiting misuse. Success criteria are the measurable signals that tell you whether the system is doing what it is supposed to do. And this is where beginners should be careful. Many people assume success means the AI feels smart, but a system can feel impressive and still be unsafe or unreliable. A well-defined requirement might specify that the system must not output certain types of sensitive information, or that it must provide explanations for decisions in regulated contexts. This stage is also where teams decide what boundaries exist, such as what the system is allowed to do and what it must never do. If boundaries are not defined early, they become arguments later, usually after the system is already in motion and harder to change. Clear requirements and success criteria are like guardrails that keep the project from drifting into risky territory. The next stage is deciding how the system will be built, which includes the overall design and the sourcing choices. Some organizations build their own models, some use vendor models, and many use a combination, like taking a pre-built model and adapting it to their needs. Beginners should understand that these choices affect security because they change where data goes, who controls updates, and how much transparency you have. If you use a vendor service, you may gain speed but lose some visibility into how the model works internally, and you may depend on the vendor's security practices. If you build internally, you may gain control but take on more responsibility for protecting data and maintaining the model over time. Design also includes deciding how the model interacts with other systems, like databases, document stores, or user accounts, and every connection becomes a potential pathway for data exposure. It helps to picture the model as one component inside a larger machine, not the entire machine by itself. The design stage is where you decide what parts exist and how they connect, which is why it is a critical point for managing risk. After design comes data planning, because data is the raw material that shapes what the AI system learns and what it can do. Teams decide what data they need, where it will come from, what permissions apply, and how it will be stored and protected. This is also where many AI projects get into trouble because data is often messy, incomplete, or collected for a different purpose than the new AI use case. Security and privacy risks rise quickly here because data can include personal information, confidential business documents, proprietary code, or sensitive communications. Data planning should include decisions about minimization, meaning collecting and using only what is truly necessary, because more data often means more exposure. Another major concern is data provenance, which means understanding where the data came from and whether it can be trusted. If you do not know where data came from, you may be training on information that is incorrect, biased, or legally restricted. Good AI security management treats data as something that must be governed, not just gathered. Once data is planned, the next stage is data preparation, which is the often invisible work of cleaning, labeling, organizing, and transforming data into a form that can be used. Beginners should know that this stage is not just technical housekeeping, because choices made here can create fairness problems, reliability problems, and security gaps. For example, how you label data can influence what the model learns, and if labeling is inconsistent, the model may behave unpredictably. If sensitive identifiers are not removed or protected appropriately, they may end up embedded in the training process or appear in outputs later. Data preparation also includes deciding what is training data and what is test data, because you need a separate way to evaluate the model honestly. From a security perspective, data preparation should include integrity checks so the data has not been tampered with, especially if it came from multiple sources. Think of this stage like preparing ingredients before cooking. If ingredients are spoiled, contaminated, or mislabeled, the final meal can be harmful even if the recipe is correct. The model is the recipe, but the data is the ingredient quality. Then comes training or adaptation, where the model learns patterns from data or is adjusted to perform a specific task. Depending on the approach, training could mean building a model from scratch, fine-tuning an existing model, or configuring a system that uses a model with task-specific instructions. Beginners often imagine training as a single event, but it is better to think of it as a controlled experiment that must be documented. The training process has parameters, versions, and decisions that affect outcomes, and those decisions become important later when you need to explain behavior or investigate issues. Security concerns in training include controlling access to training environments, protecting the training data, and ensuring that training artifacts are not exposed to unauthorized people. Training can also be vulnerable to manipulation if attackers influence the data or the process, causing the model to learn harmful patterns. Another subtle risk is overfitting, where the model learns the training data too closely and fails to generalize, which can lead to unexpected behavior in real use. Training is where capability is created, so it is also where mistakes become expensive if not caught. After training, the life cycle moves into evaluation and testing, which is where you check whether the system meets its requirements and whether it behaves safely. Evaluation is not just checking accuracy, like how often the model gets a prediction right, but also checking for harmful behavior, like producing sensitive information, generating misleading outputs, or making unfair decisions. Testing should include stress conditions, meaning situations that try to push the system into failure, because real users and real attackers will do that naturally. Beginners should understand that AI testing is tricky because outputs can vary and because the system might behave differently depending on input phrasing or context. This is why testing often involves defining acceptable ranges, unacceptable behaviors, and clear escalation rules. Security testing also looks at how the system handles access, logging, and misuse, not just whether the model is smart. If testing is weak, the organization will discover failures in production where the impact is larger and public. In lifecycle terms, evaluation is the last strong chance to catch issues before the system meets real people. Once evaluation is satisfactory, the next stage is deployment, which means putting the AI system into an environment where users can interact with it for real work. Deployment includes technical release decisions, but for beginners, the key idea is that deployment changes the threat landscape. In development, only a small group may have access, but in production, many users or even customers may interact, and that means more opportunities for misuse and more consequences for mistakes. Deployment also includes decisions about how the system is presented, what warnings or guidance exist, what controls restrict use, and how access is granted and removed. Another major deployment concern is integration, because the AI system may connect to sensitive systems, like customer databases or internal document repositories. Every connection should be treated as a pathway that must be controlled and monitored. Deployment is also where version control matters, because you must know exactly what model version and configuration are running if you want to investigate a problem later. The system is now part of the organization's operational reality, so it must be treated like a live service that needs ongoing attention. After deployment, the life cycle continues into operations and monitoring, which is often the stage people forget when they are excited about launch. Monitoring means watching the system's behavior over time, including performance, security events, user feedback, and drift. Drift is a simple concept. The world changes, user behavior changes, data patterns change, and the model's behavior can slowly become less accurate or less safe. Monitoring also means detecting misuse, like users trying to extract sensitive information or using the system outside its intended scope. In AI systems, monitoring is not only about system uptime, but also about output quality and risk signals, such as whether outputs are becoming more unreliable or more biased. Operations also includes incident response planning, because you need a plan for what happens if the model causes harm or if data is exposed. Beginners should understand that the life cycle does not end at deployment, because an AI system is dynamic and requires active management. The best security programs treat monitoring as an everyday routine, not a panic button. Another crucial stage is change management, which is how updates, fixes, and improvements happen without breaking trust. AI systems change for many reasons, like improving performance, responding to new threats, addressing compliance changes, or adapting to new business needs. Every change can introduce new risk, so changes should be controlled, documented, tested, and approved appropriately. This includes model updates, data source changes, prompt or instruction updates, and integration changes with other systems. Beginners should realize that even small changes can have surprising effects, because AI behavior can be sensitive to shifts in inputs or context. Change management also matters for evidence, because if you cannot explain when something changed and why, it becomes hard to defend decisions to leaders or regulators. This stage connects back to governance, because governance determines who is allowed to approve changes and what checks must happen first. In real work, unmanaged change is one of the fastest ways to lose control of system risk. Over time, every AI system also reaches a stage where it must be retired, replaced, or significantly redesigned, and retirement is part of the life cycle too. Retirement might happen because the business no longer needs the system, because the system is too risky, because better options exist, or because regulations change. Retirement is not just turning something off, because you must consider what happens to data, logs, access, and dependencies. If data is retained unnecessarily, it becomes long-term exposure, and if access is not removed, it becomes a lingering security gap. Retirement also includes updating inventory records so the organization does not think a system exists when it does not, or worse, forget that it exists when it still does. For beginners, it helps to see retirement as a final act of responsibility. You close the loop cleanly so risk does not remain hidden. Many security incidents come from forgotten systems and forgotten data, and AI projects can become forgotten too if they are not managed with discipline. A complete life cycle view includes the end, not just the exciting beginning. As we wrap up, the most important lesson is that an AI system life cycle is a sequence of decisions, not a single technical build, and security becomes much easier to manage when you know where decisions belong. Purpose and scope set the boundaries. Requirements make goals testable. Design and sourcing shape visibility and dependency. Data planning and preparation control exposure and integrity. Training creates capability. Evaluation checks safety. Deployment changes the risk environment. Monitoring watches behavior over time. Change management prevents drift and surprises, and retirement closes out remaining risk. That story is simple enough to say out loud, but it is powerful because it gives you a map for where to ask questions and where to expect controls and evidence. When you hear exam questions that describe a system at a certain stage, You can match the stage to the right kind of management action. That is exactly how you move from feeling new and uncertain to feeling like you can reason through AI security work with confidence.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.